Hello everyone. Today I will show you 4 tips for repairing drill batteries using household items. Simple and easy to find. I'm opening up this old DeWalt case. Inside, you'll find my cordless drill and its battery. This drill has served me well, but recently, the battery just wouldn't hold a charge. I'll remove the battery from the drill to inspect it. As you can see, when I try to attach it, it simply doesn't power on. This indicates a significant issue preventing it from functioning correctly, which is why I'm looking to bring it back to life. Placing the battery on the charger confirms my suspicion. It doesn't show any signs of charging, which is very common with older or neglected batteries. I'm going to test the battery with an LED light bulb. I'm connecting the alligator clips to the battery, but the light bulb doesn't work at all. When I connect the light bulb to the charger, and as you can see, the light bulb lights up immediately. This confirms that the charger is still working, indicating that the problem lies with the old battery itself. Now, let's tackle this dead battery. The first step is to carefully open the battery pack. I'm using a small screwdriver to remove the screws holding it together. This gentle approach is crucial to avoid damaging the internal components, which might still be salvageable. Once all the screws are out, I can carefully pry open the casing. With the casing open, you can see the internal circuit board and battery cells. There's some dust and debris, so I'm using a brush to gently clean everything. It's important to remove any buildup that could interfere with conductivity or cause future issues. Now, I'm carefully unscrewing and removing the circuit board from the battery cells. This separation is necessary to get better access to the individual components and check for any specific points of failure. Next, I'm preparing for a more thorough cleaning. I'll grab some cotton swabs. These are perfect for reaching small crevices and delicate areas, ensuring a meticulous cleaning process. I'm applying WD-40 to a cotton swab and carefully cleaning the circuit board. WD-40 acts as a great degreaser and moisture displacer, which can help clean up any corrosion or residue that might be affecting the board's performance. Now, I'm carefully peeling back this green insulation layer to expose the metal battery contacts even further. Using a screwdriver, I'm gently scraping these contact points. This ensures maximum electrical contact surface area. I'm spraying a bit more WD-40 directly onto the battery cell connections. Then, I'm using a small piece of sandpaper to gently buff the contacts. This abrasive action helps to remove stubborn corrosion and create a fresh, conductive surface for optimal power flow. I'm taking these small magnetic rings and preparing them to create new connection points for my homemade charging device. I carefully use wire strippers to strip a small section of insulation from one end of the red wire. This exposes the copper wire, which is essential for making good electrical contact in the next step. I twist the wire around the magnetic ring to ensure a secure and conductive connection. I will repeat this with the blue wire and attach a magnetic ring to it. With the wires stripped, I'm going to attach them to these small crocodile clips. The red wire goes to the red clip, and the blue wire to the blue clip. This setup will allow for temporary, secure electrical contacts. Now, I have a car battery here. I'm attaching the magnetic clips I've prepared to the battery that needs reviving. The red alligator clip connects to the positive terminal, and the blue clip connects to the negative terminal of the car battery. This creates an external connection point to regulate the battery voltage. This is a crucial step in reviving our battery. This provides a surge of power to wake up the internal cells of our Makita battery. Once I've given it a little boost, I carefully disconnect the external battery and the modified wires. With the internal components now cleaned and revitalized, I'm carefully reassembling the battery pack. Then, I bring the two halves of the casing together, aligning them perfectly. I'm putting all the screws back in to secure the casing. A quick check of the battery indicator shows multiple lights. Placing the now revived battery back on its original charger, you can see the charging red lights illuminate. I'm snapping the battery back into the drill. Let's give it a test. Hear that? It's working perfectly again. To demonstrate its full functionality, I'm using the drill to install some L brackets on the wall. This shows that the battery isn't just holding a charge, but it's also delivering consistent power for demanding tasks. It's great to see it perform just like new, proving that you don't always need to buy new when something breaks. Our revived drill battery is now powering this convenient wall-mounted storage bin. Moving on to the second tip, I'm putting the drill back on the battery to test it. And as expected, the drill isn't working, indicating the battery is completely dead. I will repeat the process of cleaning the circuit board and battery cells with cotton swabs. I'm taking a small box and opening it to reveal some safety pins. I'll use the safety pins to prepare them for creating new connection points for my homemade charging device. I carefully use wire strippers to strip a small section of insulation from one end of the blue wire. This exposes the copper wire, which is essential for making good electrical contact in the next step. I twist the wire around the safety pin to ensure a secure and conductive connection. I'll repeat this with the red wire and attach a safety pin to it. At the other end of the blue and red wires, I strip the wires and will attach them to these small alligator clips. Now, I have a car battery here. I'm connecting the red alligator clip to the positive terminal of the battery and the blue wire to the negative terminal. Then I will secure the safety pins to the contact points on the faulty battery. This provides a surge of power to wake up the internal cells of our battery. With the circuit responding as it should, it's time to reassemble our battery pack. I'm carefully placing the circuit board and battery cells back into their original positions, ensuring all the wires are tucked in neatly and securely. Then, I'll fit the top casing back on and begin tightening all the screws firmly. I'm placing the fully reassembled battery back onto its original charger. Look, the charger light immediately turns red. This means our cleaning and jumpstart method worked perfectly to restore its functionality. Let's connect the battery to the drill again. Hear that powerful whir? The drill springs to life with full power and drills effortlessly into the wood. It's working perfectly. Our drill battery is fully functional again, thanks to a bit of careful cleaning and attention to detail. This simple, yet effective, fix saved a perfectly good drill battery from the trash. Moving on to the third tip, I'm experimenting with an angle grinder and a battery. I'm opening the battery and cleaning the internal components. Now let's prepare our laptop charger. I carefully peel the insulation off the wires to expose the copper strands. These strands will be used to make a direct connection to our battery. To check if the power adapter is working correctly and providing the correct voltage, I'm connecting it to my multimeter. As you can see, it consistently delivers around 19.80 volts. This is ideal for charging our battery. This ensures our power supply is reliable. Now I'm attaching alligator clips to the stripped wires of the power adapter. Before continuing, I'm measuring our battery again. With the multimeter, it shows 0.08 volts, confirming that it's completely depleted and really needs to be restored. Next, I connect the prepared laptop charger directly to the positive and negative terminals of the battery pack. After connecting, I plug the adapter into the power outlet. Creating a bypass path for this internal circuit allows us to quickly restart the battery cells. I'll let it charge for a while to recover the battery cells. After a while, I disconnect the laptop charger from the battery to check the battery status. I check the voltage again with a multimeter. And immediately, we see the voltage reaches a good 18.99 volts. Our dead battery is recovered and ready to be reassembled. I screw the case back on, making sure all the screws are tightened to secure the battery. I connect one end of the battery to the charger and, as you can see, the red light shows it's charging as expected. Our improvements have been effective in getting the dead battery working again after a full charge. I disconnected the charger and reconnected the fully charged battery. And immediately it worked instantly. Amazing! It's incredible that it only required cleaning and direct charging. You can see how easily our angle grinder cuts metal pipes. This project proves that with a little ingenuity, you can salvage items from the scrapyard and extend their lifespan. Moving on to the final project, I'll be repairing this faulty battery using wooden tongs. It sounds impossible, but watch how I do it. I'll repeat the cleaning steps to prepare the battery for modification. For our next ingenious step, I'm taking a couple of ordinary plastic clothespins and disassembling them. I'm extracting the small metal pins, which are surprisingly useful components for creating custom electrical connectors. I'm now stripping the ends of some red and blue electrical wires. Then, I'm carefully twisting the stripped wires around the metal pins I extracted from the clothespins. These homemade terminals will provide a secure connection for our external charging method. To complete my custom charging leads, I'm attaching small alligator clips to the other ends of the red and blue wires. These clips will allow for a temporary, yet secure, connection to our external power source. I'm attaching the metal pins to the terminals on the battery. I'm carefully connecting my modified battery pack to a larger car battery using the custom alligator clips. It's incredible to see power flowing back into this dead battery. The charging process is complete, and our revived battery is ready for its final tests. I'm carefully reassembling the battery pack, ensuring all components are properly seated and the casing is securely screwed back together. Time for the ultimate test. I'm placing the fully repaired and reassembled battery pack back onto its original charger. Look, the red light is on, indicating it's now charging correctly without any errors. I'm snapping the repaired battery back into the angle grinder. Watch as I press the trigger. It works perfectly, running at full power. The angle grinder easily cuts through the marked metal bar. This just goes to show you don't always need to buy new. A little DIY magic can save the day and your wallet. If you enjoyed these 4 amazing battery revivals and found this project inspiring, hit the like button on this video, share it with your friends, and leave a comment below letting me know what other unexpected fixes you'd like me to do. Don't forget to subscribe to the channel for more great DIY ideas. Thanks for watching, and see you in the next video.